Hello and welcome to this video on Surds. We're going to start off with some revision of what you did at GCSE. So for example, you might have been asked to simplify root 48, and the most efficient way of doing this is to know the largest square number that's a factor of 48, which is 16, and you can rewrite root 48 as root 16 times root 3. Root 16 is 4, so the final answer is 4 root 3. And if you type root 48 on your calculator, it will automatically simplify it to 4 root 3. You might have been asked to simplify two or more surds added together, in which case they would have had the same surds at the end, so that you could then collect them together. So for example, root 45 is the same as root 9 root 5, root 80 is root 16 root 5, and root 20 is root 4 root 5, so all of those contain root 5 as well as a square number. So 2 root 9 root 5 is the same as 2 times 3 root 5, which is 6 root 5. 7 root 16 is the same as 7 times 4, so that gives us 28 root 5. And 3 root 4 is the same as 3 times 2, so that's 6 root 5, but we're subtracting it. So once you've done 6 root 5 minus 6 root 5, you're just left with the 28 root 5 as the final answer. You will also have been shown how to rationalize the denominator of a fraction, where the denominator will be a surd, and our final answer will not have an irrational denominator. So to do that, we multiply by a fraction which is equivalent to 1, so we're not fundamentally changing the fraction, and we use whatever the surd is on the denominator, we can use that as our numerator and denominator. Hence that has a value of 1. 30 times root 5 is 30 root 5. Root 5 times root 5 is 5. And then the 30 and 5 cancel down to give us a 6. So our final answer is 6 root 5. You should have been shown how to expand brackets, which contain surds. It's a bit similar to when we're expanding brackets with x's in, except we're only going to get 2 terms normally in our final answer, assuming that both brackets have the same surd, in this case root 3. So 2 root 3 times 1 is 2 root 3. 2 root 3 times root 3 is the same as 2 times 3, so that's 6, except it's negative because of the minus sign in front of the root 3. Negative 4 times 1 is negative 4, and negative 4 times negative root 3 is positive 4 root 3. We can collect the 2 root 3 and the 4 root 3 together to make 6 root 3, and negative 6 take away 4 is negative 10. A similar question, except this time we end up with an answer which is just a rational answer, because the 2 irrational terms in the middle, the 2 surds, are going to cancel out. We're doing something similar to our difference of 2 squares. So we're doing 5 times 5, which is 25, and we're doing negative root 3 times positive root 3, which is negative 3, and then the 5 root 3 and the minus 5 root 3 cancel out, so our final answer is 22. As an extension task, I suggest that you might like to try writing a pair of brackets in the form p plus root q times p minus root q, where q is a prime number and for which the final answer is 1 or 2 or 3, etc. And again, if we have 7 take away root 3 and 7 plus root 3, the final answer is the same as 49 minus 3, which is 46, and will enable us to do the next question. Now, since p plus root q times p minus root q is always going to be a rational number, we can use that principle to rationalize the denominator where we have 2 parts on the bottom, like 7 minus root 3. So to do that, we do a similar thing. We're going to times it by 1, but because 7 minus root 3 times 7 plus root 3 is going to give us our 46, we're using 7 plus root 3 top and bottom, so i.e. the version of the surd which has a plus rather than a minus. On the numerator, we get 77 plus 11 root 3 plus 35 root 3 plus 15. The 15 comes from 5 root 3 times root 3. If we add those together, we get 92 plus 46 root 3. The denominator is 46. 92 divided by 46 is just 2. And 46 root 3 divided by 46 is root 3. So the final answer is a nice and simple 2 plus root 3. Here are 5 more fractions for you to rationalize the denominator for. And so please pause the video and give it a go. Answers in a separate slide. If you wanted to expand 1 plus root 2 to the power 5, you could just type it on a calculator, but obviously sometimes they would like you to show these things. So what I've done is to split it into 1 plus root 2 squared, 1 plus root 2 squared, and 1 plus root 2. 1 plus root 2 squared is the same as 3 plus 2 root 2. So then I've times 3 plus 2 root 2 by itself to give me 17 plus 12 root 2, and then multiply that by the other 1 plus root 2 to give me a final answer of 41 plus 29 root 2. And at some point in the future, you'll be able to use the binomial expansion to do that slightly more efficiently. Here's a question for you to try if you'd like to pause the video. You've been given that root 2 minus 1 all to the power 6 is equal to 99 minus 70 root 2, and you've been asked to find out what root 2 minus 1 to the power 4 is and what root 2 minus 1 to the power 7 is. By hand, without just typing on a calculator, answers will appear in a separate slide. Here's an example of a quadratic equation for which one of the coefficients is a surd. We have x squared minus 3 root 5 x plus 10 equals 0. Now it does actually factorize because root 5 times 2 root 5 is equal to 10, because 2 5s are 10, and root 5 plus 2 root 5 is 3 root 5. We will need to make them both negative in order to add up to negative 3 root 5, but they still times to make positive 10. So the answers are root 5 and 2 root 5. Here is another quadratic equation with a surd coefficient for you to try. Again, answers in a separate slide. And finally, here is an independent study assignment for you to have a go at. Answers to be revealed at some point.